We introduce our work, BEVRestore, addressing diverging training costs, using our restoration of BEV as the upper right figure. This approach is for effective but costly efficient association of high-resolution BEV map generation as shown in the below figure. For generation of semantic surround maps, our suggested framework takes in camera images and LiDAR points. Then the model encodes BEV features of surround view, obtained from the sensors. This task facilitates the representation of large-scale scenes, but it requires costly expensive hardware specs due to the model's bulky architecture. As a result, the model's large cost consumption imposes the use of low-resolution BEV space. And the limitation causes imprecise surround perception as the below right comparison. So, to address the cost inefficiency for precise perception, we should address this problem. To resolve the issue, we introduced the super-resolution in BEV space. Our proposed method employ LR BEV space, and super-resolve it to high-resolution BEV space. This approach, BEVRestore, is a plug-and-play solution for dense HR map construction. BEVRestore is applicable to various upscale factors and enables fine-grained map generation as shown in the below figures and table. However, for too large upscaling factors, BEVRestore may suffer from the lack of local details, as the comparison between 4 and 8 scale factor BEVRestore. In our empirical observation, the proposed mechanism shows scalable applications across diverse sensor modalities and backbones for effective map generation. In the first table, BEVRestore demonstrates its applicability to the LiDAR, camera, and their fused features. The experiments in the second table indicate our restoration strategy's scalability to the vectorized HD map construction. In addition, owing to the LR BEV's small-sized space, BEVrestore's super-resolution addresses cost divergence of heavy models for constructing HR maps, reducing inference latency and backpropagation memory. Compared to the handcrafted upsampling, the learnable methods, deconvolution and a sub-pixel convolution with pixel shuffle effectively interpolate the nonlinearity of a BEV feature, providing a fine-grained representation. However, the restoration costs sometimes over its benefits. Especially, for a lightweight vanilla models, it may be dominant as in the results with HDMapNet. Despite that, our restoration strategy is powerful for addressing cost divergence from learning HR BEV space with bulky models as in the comparison with BEVformer. Map construction with BEVrestore sometimes causes an overconfident issue, which is a kind of an overfitting. For example, as in the below figure, if a part of view is occluded, BEVrestore's approximation may be imprecise. Thank you for watching.